Hey guys, welcome to your Unit 9 test study guide. I'm going to go ahead and go through all the problems this time. So let's go ahead and begin with question 1. We're being asked to do a couple of things for these. We're going to be asked to find the y-intercept, the horizontal asymptote, and then we also want to sketch the graph. So let's go ahead and start here with number 1. The y-intercept can be found by doing A plus C. On this particular problem, the A is 2 and the C is -4. And so my y-intercept would be -2. And that means that's where it touches the y-axis. Next, we're going to find our horizontal asymptote. That is located at y equals c, and therefore, since c is -4, that's where my horizontal asymptote will be. So -4 is about here. And then finally, we get to determine the shape of this graph. The shape is based on the a value, and it's also based on the b value. We have a chart that I provided you guys with earlier. So if b is greater than 1 and a is positive, then the graph looks like this. Whereas if b is less than 1 and a is positive, the graph looks like this. Now if a is negative and b is greater than 1, I should redraw that actually. It gets flipped upside down, so it would look like this. And if a is negative and b is less than 1, then it gets flipped upside down also. So there's our options. So in this case, my a value, as we said, is 2, and 2 is greater than 1. And my b value is 1/2. Oh wait, you know what? I just goofed up a little bit. My a value is 2, which means it's positive. That's all that we care about. We don't care about it being greater than 1. We only care about whether a is positive or negative. So my a is positive. That's all we care about. Now the b value is 1/2. That's the one we care about being greater than or less than 1. 1/2 is less than 1. So since I have less than 1 and positive, this would be my shape. So, sketching this graph then, it's going to hit my y-intercept and get flat on the left side like so, and be up on the right side like that. Go ahead and check out the next one. So number 2, we're missing our c value, and we have to remember that when you're missing your c value, it's 0. Now we're ready to begin the rest of the problem. The y-intercept is a plus c. My a value is -3. My c value is 0, and therefore my y-intercept is -3. So we put a dot at -3. The horizontal asymptote is y equals c, which in our case c is 0. And therefore my horizontal asymptote will be the x-axis itself. That's where y equals 0. Next, we're going to look at our a value. It's -3, so that's a negative a value. And my b value is 2, which is greater than 1. So we have a negative a, and we have a b value greater than 1, which means we'll be using this shape, which would look like this. And there's that graph. For this particular problem, we're missing the a value. They give us the problem written like this, but that means that the a value is 1. So anytime you're missing the a value, it's a 1. So to find my y-intercept then, it's 1 plus the c value, which in this case is -7. So we put a dot there. The horizontal asymptote is the c value, which is negative 8. So we put a line there. My a value is a positive. My b value is greater than 1. So with a positive a greater than 1, we have this shape. All right. So that's graphing exponential functions. So move on to our next problem. For numbers 4 and 5, we're being asked to determine if the data represents an exponential function. The way we could see that is based on what exponential functions are. Exponential functions are functions where consecutive y values increase by a common multiple. And so, looking at the y values, the question is, if I divide 0.02 by 0.2, what do I get? Well, I believe that would be 1/10, if I'm not mistaken. Now, if I were, or you could say 0.1 if you want to think of decimals. You could do it on a calculator if you like. And then you do 0.002 divided by the one before that. And I also get 0.1. And 0.0002 divided by the one before that is also 0.1. That means that we're going up by a common multiple every time. Every time, in order to get from one y value to the one after it, we're multiplying by 0.1. So if I take 0.2 and I multiply it by 0.1, I get that. And if I multiply that by 0.1, I get that. And if I multiply that by 0.1, I get that. That means that's my b value in my exponential function. That's the value that I'm multiplying by repeatedly. In other words, it's exponential. So this is an exponential function. Number 5, same thing. Just got to see if it's exponential by looking for that common growth factor there. So let's do it. 8.44 divided by 3.2. Get your calculators out and give that a try. You should get 2.6375. Try the next pair. We get 15.67 divided by 8.44. And we get 1.857 approximately. Those are not the same, and therefore this is not exponential. I want to use this table here on number 6 to actually create an exponential function. Might be helpful to look back at your notes. This is a challenging exercise that we spent 2 days on, so let's go ahead and jump in here. So the first thing I recommended when doing this was to rewrite the table. My x value starts with 1, and my y value is 0.8, and then after that they go to x equals 4, and they end on 0.0064. And we're missing some numbers in between x equals 1 and x equals 4, so we're missing x equals 2, and we're also missing x equals 3, and we have no idea what the y values are for those because they didn't give them to us. But now that we have our consecutive, meaning one after the other, values established, we know that if this is exponential, which it is, I should be multiplying by the same thing each time to get from one y value to the next. So if I multiply 0.8 by something, we'll call it b, then I should get this number. And if I multiply it by b again, it should give me the next number. And if I multiply it by b again, it should give me the last number. In other words, if I take my first y value and I multiply it by b 3 times, it should give me my last number. So from here, we're going to solve for b. The first thing that you're going to do to solve for b is divide both sides by the 0.8. I get 0.008. Next, we want to get rid of that third power next to the b so I can solve for b itself. To do that, we raise both sides to the 1/3 power. And on the left side here, those cancel out, leaving me with b. And on the right side, we get to use our calculator again, and I end up with 0.2. The next step is to find our a value. To find your a value, you're going to harken back to what exponential functions look like. And we're going to plug in a number for b, which we already know is 0.2. We're going to plug in a number for x, which I'll use these 2 points. The x value is 1. And I'll plug in a number here for y, which is 0.8. Both of those last two came from our first point. Now you could use your second point, but I like to pick the ones with the smaller or easier numbers. So if I plug those things in, I have the following. The first thing we got to do to solve for a is to do this power here, 0.2 to the first power. Now if you raise 0.2 to the first power, it just stays as 0.2. I'm going to move it to the front of the letter though, so it looks more like what we usually see in math. The next thing we're going to do is we're going to divide both sides by 0.2. And we get a equals 4. And that brings us to the end of our problem. We now can write the equation of our exponential function simply by putting what we got for a here and what we got for b here. And so the final answer would be 4 times 0.2 to the x power equals y. All right, so the next few problems we're going to work on are word problems. Now, I believe that we have gone over 4 different types of word problems, and part of the trick is recognizing when to use each of those word problems. In our last lesson, I showed you guys this slide. Now, if you see the word continuous, we're using this formula. If you guys see the word compound, but not continuous, we'll use this one. So by the way, this one up here will also say compound, but this one says compound without the word continuous. That would be this one. So continuous compounding, not continuous compounding. Next, you'll see some other types of exponential functions that don't include the word compounded at all. And what they do is they give you a growth rate. For those, you'll use this formula. And then finally, the ones that don't give you a rate or a compound, those are the 2-point problems where you solve them with the table, like we did in the last exercise on the study guide. So let's go back to our study guide and see what type we're looking at right now. All right, so number 7 says an employee's initial salary is $75,000. After 9 years, the employee's salary is $89,751.45. Write an exponential function. So before we begin, what type of word problem is this? Well, notice that I don't see the word compounded, so I know that it's neither of the first 2 options that I showed you. Second, notice that the word rate is not included up here at all. They did not give us a rate, so it's not the third one. And therefore, this must be the one where we use the table. Now, it doesn't always have to be this way, but I told you that for my class it will be. I'm always going to give you the starting amount. And since that's the starting amount, the x will be 0, and the dollar amount that goes with that will be the y value. Okay? The other pair of numbers will be your second point. After that, we're going to solve this just the same way we did the other one. It might be good to go ahead, though, and label what these variables mean. X refers to years, because if you sit here, it says 9 years, right? And that's our x value. So x is a year value. Y is the other number, which is money. That's the salary. Okay? So it's helpful in word problems to make sure you know what your variables represent. But for part A, it's going to be just like the last problem we did on number 6. So if you didn't see that or didn't do it and you want to review, go back. But in the meantime, I'm just going to show all my work here and the final answer because it's just like the last one. I'm not going to go through it carefully, but I will show my work. All right, so there's the work for you. You'll notice that I didn't show my work for the part of finding A, and that's because you don't have to on these. With these word problems, if you have the starting amount, that is your A value, and so that's what goes right in front here. You have to calculate it. but I do have my work shown for finding the B value, which is 1.02. All right, let's go ahead and move on to part B. It says find the growth rates. Now, back when we did these problems, I did not ask you this question, but I did ask this question when we did other types of word problems, but the same principle applies. The growth rate, the growth factor is the result of taking your growth rate and either adding it or subtracting it from 1. Okay? So I'm looking for the growth rate right now, but I know my growth factor. My growth factor is this number here in parentheses. And I'll just call the growth rate R for now. Now we have to decide, is it plus or is it minus? Well, in this story problem, you can see that his salary was $75,000 and it went up to $89,000. So that means this is an increasing function, which means we would use plus. To find the growth rate, we just subtract the 1 in this case, and I get 0.02. Now, you could also write this as a percentage. If you ever want to change a decimal into a percentage, you simply multiply that by 100, which basically just takes this decimal and moves it over twice, so it becomes 2%. Okay? Now, on your test, the fact that it's a positive, I'll put a plus there to indicate that it was a positive here, and if it's a negative, then I'll put a negative there. But there's our growth rate. Now, the next question is asking us, what is the employee's salary in 20 years? Well, as we said earlier, X represents years, Y represents salary. So if I wanted to find out what the employee's salary will be in 20 years, I just need to plug 20 in for X, and we'll see what we get there. Once again, this is a calculator exercise, and that's what we get. Now, make sure that as you guys are working through these exercises here that you are actually trying this stuff on the calculator rather than just writing down what I put, because on the test, you're going to need to know how to use your calculator. All right? All right, let's go and take a look at question number 8. It says the population of a town increases by 2% every year. The town's initial population is 52,000. So notice that we've got some keywords here. Increasing, 2%, an initial population of 52,000. All right, so this is, do you notice that we have to decide what kind of a word problem we're looking at here? Well, notice I do not see the word compounded. So it's not going to be either of those two options that I showed you earlier. Let's see if I can find it here. It's not going to be type 1 or 2 because both of those require the word compounded to be present. Okay, but it does have a growth rate there. That's my growth rate. Notice that it's increasing, so that means my R is positive. And whenever we have these, we're using this type of a formula. Okay? In these types of problems, this is the starting amount. This is your growth rate. And then you have to decide whether it's plus or minus. All right. Well, first of all, let's start by finding our growth factor. As we've already mentioned, the growth factor, which is B, is equal to 1 plus or minus R. Now, we already know what the R is in this case. It's 2%, which is, if you take 2 and divide it by 100, you can change it into a decimal, which is 0.02. We also know already that it's increasing, so that's a plus. And to find my growth factor, which is B, we simply need to add those two values together. So there is my growth factor. Now we're ready to write an exponential function. When you write your exponential function, you put your starting amount here, which we said was 52,000. You put your growth factor next, which is 1.02, and then your x goes here. All right, so that takes care of part B. Part C, what will the population be in 5 years? Well, X represents time, Y represents population. So, Y is equal to 52,000 times 1.02 to the power of 5. Which, once again, we're going to use our calculators for that. And there's our population there in 5 years, 57,412. All right, moving along to number 9. It says Daniel invests $2,600 in a savings account with a fixed annual interest rate of 4%, compounded 4 times per year. So some important information here. The first thing I want to point out, she says compounded. Notice that it doesn't say compounded continuously, and so we're using this formula here. Okay, where P represents the starting amount, R represents your growth rate, N represents the number of times compounded. And it's written in 2 places. And then T is time. And time will always be in years for these types of problems. Okay? So now we know what type of problem or formula to use for this one. It's a compound interest without continuous growth. So we're just doing the regular compound problem. This here represents our starting amount. This here represents the R value, which as a decimal would be 0.04. This here represents how many times it's being compounded, which is 4. And then now we're ready to go ahead and do part A, which is to write an exponential function to model this scenario. So we have A is equal to the starting amount multiplied by 1 plus the growth rate over the number of times it's compounded per year. And we'll just put T here for now because we don't have a time to plug in. They just want us to write an exponential function. Now, we should simplify this a little bit. To simplify the inside here, we're going to do 0.04 divided by 4 first on our calculators there. Or you can maybe do it all at once, but you have to be careful about how you do that. For now, I'll just do 0.04 divided by 4, and I get 0.01. And then we can add these together. And I get 1.01. So there's my exponential function for part A. For part B, the question is how much will he have after 5 years? We just need to plug 5 in here for T. Now 4 times 5 is 20. So if we just punch that into our calculator, we'll get our final answer. There we have it. $3,172.49 would be the amount in the account after 5 years. We'll move on to our next question. Now, from the process of elimination, you guys can probably imagine which type of word problem this is going to be. But more specifically, we can tell what kind of word problem this is because it says compounded and continuously. When you see those 2 words together, we're using the PE to the RT problem there. Remembering that this is my starting amount. R is my rate. Now we have to remember here that for these types of problems, the R could be positive or negative, depending on whether we're dealing with growth or decay. All right, T represents time. So here it says Ted invests $7,539, that's my P value, into a savings account with a fixed annual interest rate of 5%. Now, whenever you're doing savings accounts, they're adding money to your bank account. They're not reducing it. So this is going to be a positive 0.05. If you ever see any kind of indication that this is a word problem where they're going to be reducing an amount of something, then you want to make sure that you keep in mind it could be negative. But in this case, it's positive. It says here, write an exponential function to model this scenario. All right, so that would be, for part A, y equals the starting amount multiplied by e to the power of r t. And that is part A. Let's go ahead and check out part B. It says, use the exponential function to find how much he'll have after 10 years. So for that, we're just going to plug 10 in for t. Now, first of all, if I multiply those, I end up getting this. And then I would punch that into my calculator to get my final answer. And there you guys have it. For part B, the answer would be 12,429.71. Make sure you know how to find the E button on your calculators. All right, let's go ahead and continue here. We're on number 11. Question for number 11 says, determine if each function below represents exponential growth or decay. Now, there's two ways to identify growth and decay. One way is by looking at the B value. For exponential growth, the B value, the growth factor, is greater than 1. For decay, it's less than 1. Another way you could tell whether something is exponential growth or not is by looking at your R value. If your R value is positive, then that's exponential growth. If your R value is negative, that's decay. Those two things go together. So in this case, I have a B value of 1.5, which is greater than 1, and therefore this is growth. For part B, my B value is 0.85, which is less than 1, and therefore this is decay. For part C, these are written in with a base of E. In that case, the number up here in the power is your R value. My R is a positive 6, which means that it is growth. Whereas for this one, the R value is negative 3, which is decay. The last one's kind of tricky. It's written in a base of E, but it's written kind of weird. The R value looks like it's 1, but there's a few ways you guys could think of this. First of all, you could rewrite it like this. You could change it to just E if you give it a negative exponent, in which case you can see that your R value is negative. Okay. Another thing you could do is you could just realize that E is a number, right? And you can realize that B is 1 over E, and that's 1 over 2.7 something or other, which is going to be a number that's less than 1. But whether you think of it as a B value or as an R value, either way, the answer is decay. Okay? Move on to numbers 12 through 15 here. Solving for exponents. When solving exponential equations, the first thing you want to do is you want to make sure that the base is the same on both sides. So for instance, I can change 25 to be 5 to the second power. Once you get the bases to match, you can ignore the bases and just set the exponents equal to each other. And after that, you're welcome to solve for k. In this case, all I would need to do is divide by a -1 to get k by itself, and I would get -2 as my final answer there. Number 13. This one's kind of a tricky problem. The way that we're going to get both of these to be the same base is I can change a 1 into a 4 to the 0 power. Any number to the 0 power is 1. So if you ever have it equal to 1, just know it's going to be this base over here to the power of 0. After that, we can ignore our base, set up an equation, and solve. In this case, I would just need to divide by 2, and the answer is just 0. Let's go ahead and take a look at number 14. This is one of these situations where you have to change the base on both sides. Now, the fact that this is written as 1/3 means I'm going to focus on the 3. 81 can be written as a 3. It's 3 to the 4th power. But I don't want to leave this as 1/3 either. I want it to be written as 3. That would be 3 to the -1 power. Now, we're going to have to multiply these powers together before we go any further. I'm going to distribute the -1 to both of those, and I end up with 3n plus 1. Now we're welcome to solve it by crossing off the bases, setting the exponents equal to each other, and doing some algebra. I might be going off the screen here, so I'm going to come up here and show you what I wrote. I'm going to -1. Divide by 3, and n equals 1. All right, one more problem to go through together here, number 15. We have 5 to the power of 2 minus 3x is equal to 5. Oh, it's not x though, it's v. 5 to the power of v minus 1. Now notice on this one, the bases are already the same, so I don't need to change the bases. We can start by just crossing those off and solving. For this one, I would put my v's together first by adding 3v to both sides. 1v plus 3v is 4v. Those cancel out. Bring down your 2. Next, we're going to add 1 on both sides. And then I have 3 equals 4v, so we're going to divide both sides by 4. 3/4 would be our final answer there. All right, our last thing we're going to do is going to do some graphing of some exponential functions here. So we're going to be graphing exponential functions that have this form. A number times e to the power of x plus a number. And it's important to remember that if you're missing a, then it equals 1. And if you're missing c, then it equals 0. So let's go ahead and begin here on number 16. So, as you can see, we're missing the a value, which means it's 1. So that's the first thing you want to do is identify your missing numbers. Step 2, we want to identify our y-intercept. The y-intercept can be found by taking the a and adding it to the c. The a is 1, and the c is a -3. And so my y-intercept is -2. So I'm going to put a dot at -2 on the y-axis. The horizontal asymptote is at y equals c, and the c value is -3. So now I'm going to draw a dotted line at -3. The last thing that we need to do is we need to determine the shape of this thing. I gave you guys a chart in our last lesson of this unit. that looked like this, where I gave you these various shapes. So, if you have a regular E, should have X's there. If you have a regular E, like we do here, and a positive A, like we do here, then we'll be using this shape. So it's going to look like this. And that's that. Let's go and take a look at 17. All right, so on number 17, first of all, let's notice that we're missing the C value, and when C is missing, it is 0. The y-intercept, once again, is A plus C. The A value is negative 3, C is 0. So my y-intercept will be at negative 3 this time. So I'm going to plot a dot at negative 3. Next, we have our horizontal asymptote, which is at y equals C. And in this case, C is 0. Y equals 0 is on the x-axis. And finally, we need to determine the shape. Now, since I have this kind of an E, 1 over E, and a negative A, 1 over E would be this shape here. And so we'll be connecting the dots like this. And there's that graph. All right, and that'll do it. Hopefully that was helpful. We'll see you guys in class.